I didn't participate in today's LeetCode contest, so let's just see what were the problems. Digit frequency score, maximum number of items, so an easy and a hard, it's the same thing. You're given an integer, the score of n is defined as the sum of d into what's d? Over or distinct integers, where frequency of d is the number of times that digit appeared. So, an n, return an integer to score. What? Score of n defined by the sum of d into frequency of that number over all distinct digits d. So how many times a number, what is the value of the number and how many times it appeared in that particular number? And the that's how you add it to the overall sum of that given number n. Overall distinct digits d set where frequency denotes. So it's just a stack and a while loop. Um, in sum is equal. What's the constraint? What are the constraints? 10 to the power of 9. I'm just going to make it long. A long answer is equal to 1. Then what do I have to do? I have to make a set of integers, call it d for distinct. It's a new hash set. Then I just do while n is greater than 0. I simply mod it. Do I mod it? Or I can just make a single, don't make a hash set. It's digits, right? What are the digits? The digits can only be a frequency. That's what's the size I need? Like 10. So like I have 0 to 9 all the digits. While n is greater than 0, well, n is greater than 0, what do? I mod it, which is n modulo 10, I get the last digit, and then I go to the frequency of this and I increase it, and then I do n divided by equal to 10, right? Then I just do for int I inside of, I need the indexes as well, I less than n, I less than 10, I plus plus, if what is the frequency of I is greater than 0, I will just answer would be equal to, you just add frequency of I into I. This is what you do. Just add a bracket around it and you just return, it's an integer. The answer is was going to be an integer. Just do int, you do an int here and you do an int here. And let's see, and let's see whether this works or not. It should. What? I have an extra output. Oh, because it's one, so just make this 0 and submit. Please run. Cool. Next problem. Maximum numbers of items from sale. The first part. We're given a 2D integer array items where items of I is this. We have a factor. I don't know what factor is, and then there's a price. We're also given an integer budget. Okay, so there's a budget, there's an items, and the items has some factor, and that some factor. I mean, it also has the price of that item. Sure, that makes sense. There are unlimited copies of each item available for your purchase. Unlimited copies. So it doesn't matter how many. You may buy any number of copies of any item such that the total cost of the purchase copies is at most. So I have to basically exhaust my budget. After buying items, you may receive free copies according to the following rules. But if you can get free copies, you can get more of the same item. For each item I that you bought at least one copy of, you receive one free copy of every item J, such that both the items are not equal, and the factor of I divides the factor of J. Okay. Buying multiple copies of the same item does not give anyone through I. Okay. The same item J can be received multiple times for free if it is received from purchases of different item types. Okay. The same item J. can be received multiple times for free if it is received from purchases of different item types. Received from purchases of different item types? What does that mean? If I'm buying the same JS item with different IS items, I think, okay, so these three rules apply for the same thing, right? If the factor of this divides this, can I brute force this using two loops? That is 36% acceptance rate. This is not going to be straightforward. Return the maximum number of item copies you can obtain, including both purchased copies and free copies while spending at most budget on these items. So I can maybe sort it out and sort all the items. But how do we sort a 2D array? That's a syntax check, right? I can do this. How to sort a 2D array in Java. How do I forgot it? I mean, I keep forgetting it. Lambda custom expression makes sense. So I can sort it based on however I want. Just keep this here just in case it comes in handy. So this will take the first based on the first whatever it is. I can just make it number one. Like sort them on the basis of prices. So I take the cheapest item. Or no, just wait. Let's just read the test cases, sample cases first before making any assumptions. You have a 6 and a 2. So the factor is 6 and the price is 2. The price is 6, the factor is 2. And then the price is 4 and the factor is 3. The budget is 9. I can buy this, this, and this. Instead of buying the middle item, I can buy the one that has this, and it also is the factor of has a factor of 6. Like 3 is divisible, or 6 is divisible by 3. So I think this should be the answer. It's not. You can buy two copies of item 0 and 1. Copy of item 2 for a total cost. What? You buy two copies of item this and this. How can I buy two copies of item this and this? It's 2 into 2 plus 4. 8. Which is not greater than this. This is like a simulation problem, maybe. It's not a simulation problem. What's perfect? Imagine I sorted it and then I start picking up the elements. But then I also have, is this a graph problem? Okay, I need to stop randomly throwing out words. An algorithm for data structures without actually understanding what the problem wants. Okay, think about it. You have a factor and you have a price. You have a budget. You have three things. The idea is to buy a maximum number of total items that you can obtain. Okay, and I have to spend at most budget on them. So this is the how much I can spend on them. Factors. So if this factor is not a prime number and there's a two or a three or maybe both, then I can pretty much make any number I want. That's one thing. What's the constraints on factor? Okay, so factor and price are both going to be between 1 and 1500 inclusive on both sides. The budget is also going to be the same. Now I'm okay. The budget is going to be the same. Imagine this. I sort the array, I buy the cheapest item, and then I check whether there's a factor of this cheapest item somewhere. Like, is this number a factor of any number? If that's the case, I can buy, I can get two items for the cost of one. And I can do that for each of the items. This is my intuition. Let me try it. Um, this int n is equal to items dot length, and then the int items or like count. Let's just say count of items. Just count in general. Then I do this arrays dot sort, but instead of sorting um, the factor, I will sort it on the basis of the price, right? Then for int I equals to 0, I less than n plus plus I. Int factor for this is going to be equal to a of 0. What's this? Items of 0. And int price is going to be items of 1. I'll run a j loop from I plus 1 till n, not I less than n, j less than n, j plus plus. Okay. If this is the cheapest item, Boolean factor exists. I should not directly buy any item, right? Because buying a standalone item might not be worth it for the overall budget. And then I can have after this like J loop, I can just have some logic in the for in this if statement to do something like what should be something like checking whether a factor exists. I mean, I'm just describing what it's doing, but you get the point. Now you yourself, this J loop will have itself a factor like a number, and it will also have a price. Let's just take this as well. What if multiple of these have? Okay, this is not going to be as simple as I thought. It's not going to be as simple as I thought because prime numbers exist. That's number one. Number two is what if the factor on the left, like the initial factor, actually no, it won't. I'm thinking like maybe there's something on the right that does not divide with the current item. Or if it even if it does, how many times can I buy this? I mean I can buy the cheapest items all I want. So I can just buy the cheapest. Okay, so to buy the cheapest item, that is allow me. No, wait, you just calculate how do you, I mean, no, you buy the cheapest item that also has a bunch of factors. So I need a factor count, I think. Let's just not care about the count right now. I make an array of frequency. I cannot make, okay, can I make this? What's the length? Length can be n, right? Wait, give me an array of frequency, name it new int. The size is going to be n. What is this frequency going to store? The number of factors per item. and the items are sorted. I mean, they're sorted by price, but whatever. Or should I just sort them by the factors? Sorting them by factors can be helpful because if I know that what would have been the total number of items, like the first test case, if I sort them by their prices, it would be 2, 4, and 6. The factors will be 6, 3, and 2 respectively after sorting. That is okay. I buy an item of 2 and then I check, hey, is there a factor of 6? Like, is 6 a factor? If it's not, don't buy this item. You move to the next item. The next item would be of price 4 and a factor 3. Like the number factor of I is going to be 3. I will traverse the rest of the array. And I will say, okay, I have an item. No, wait, what? Divides factor of 0. Okay. I have to check from the starting. So I think my original idea was correct then. Or you can just buy, what can you buy? Because for the price of one item that costs 4, I'm getting two items. I'm getting two items that cost 2. So the fact is, but also this number is, okay, now I'm thinking there's another way to solve this problem. I can buy the 4 item twice. That each of those copies is going to give me another 4 items. Like another 2, 3 copies of the first item. I would still have one left in my budget. I think this is exactly what it did. So you just sorted on the basis of factors, honestly. I mean, like, not the price, just counts the factors. Then you go for int I equals to 0, I less than n plus plus I. The factor is going to be items of 0. You don't care about the cost. For int I equals, I need j equals to 0. J will start from 0. J less than n. Um, I have sorted them on the basis of price. Sure, doesn't matter. Could have sorted them on the basis of factors as well because I'm just surprised. I cannot even decide how to sort them. Just keep it like this. J plus plus. If j is not equal to I will do one thing. That is what if that is. Let me just reverse this condition. If j is equal to I, you just continue. Otherwise, get the factor for this jth element, jth item. That is going to be items of j. And then I will check if this items of j divided by modulo by the factor of ith item equal to 0. I will go to frequency of this j and I will go a plus plus. I think that makes sense because now I'm getting this. I will go frequency of I, not frequency of j. It's frequency of I plus plus. Like this item can divide these many more items. Makes sense. Does this make sense? Not true. Why is there triple equal to? This makes sense. Int max. I need a max count. Am I recording? I am recording. 20 minutes. Cool. I have a max count that is equal to a 0. I'll go for int I in. I need the max count. Int max index equals to 0. Just make everything integer dot main value. I mean, I can just make the index -1. I can just assume that the first element, like the 0th element, is the biggest. Figure out the maximum index and the maximum count. If max count, not just if ARR of I, like frequency of I is greater than ARR frequency of max index, I can just go that hey, the max index is going to be equal to I. Don't care about the max count. When I traverse inside this array again, I can then just modulo. I think I can then just modulo the price of this maximum index item and then multiply it. The thing is, I can only get one item per that. So you get should be items of I, comma 0. This should be items of j, comma 0. In that sense, int price of max index, that is items of whatever the max index is, and the first, I'll get the price. I have to divide it by int item should be divided by the budget, that is price divided by the budget. Now I have to return however many items I have times 2, I think. Or I just completely missed the second test case. Of course I did. There's a matrix entire. It's items. This is not an easy problem. Item into 2. The solution is entirely wrong. The assumption, the intuition was entirely wrong. And the output is 0. So item 0, but why is this 0? I don't think I can solve this. Maybe I can run a while loop and then based on the value of this, maybe not. Close this problem for now. Close this for now and see one the first and recompute for every possible factor of factor f. How many times? How many items have a factor divisible by f? And I was calculating the number of factors per item. Had done that. So I'm in the kind of in the right direction. This sorting line can be ignored for now. It's the second hint. Buying the first copy of item I is special. It gives the purchased copy plus one free copy of every other item whose factor is divisible by j. Buying more copies of the same item does not create more free copies. So after the first copy, each extra purchase only adds one copy. Or knapsack style DP over items in budget where each item can be skipped for the first time what additional. Okay, I could not have solved this. I have never solved a DP problem. DP is something I'm still working through. So I don't feel bad that I was not able to solve the second problem of this contest because I have not done DP. That's the truth. I know conceptually how DP works, the tabulation form, the tabular form, and the memorization form, but I have never solved any DP problems specifically. Yeah, 9,000 people solved it. 12,000 people almost solved it. Hmm. And also, it's a second problem, so it's kind of sad. Of course, there are people who are solving these problems in 9 minutes. I'm still for a second problem. I don't know. Maybe I'm just being a bit bitter, but yeah, I could not have solved this problem. Um, I don't think it's even worth checking the third and the fourth one because they might also use PP. Lexicographically max, so that's the fourth problem. Maximum number of items from sale 2. Um, you also must use PP, right? This has a 23% acceptance rate. Maybe I could have. I don't know. Lexicographically maximum max. 54% people have solved this. That's because only 7,500 attempted it. And that makes sense. And then like a lot of people solved it. The fourth problem being solved by half the people who are attempting it, that's a lot. Or maybe the question was rather simple. Let's see. You are given an integer array. You want to construct an array result by repeatedly performing the following operation until this original array becomes empty. Choose an integer k between the lengths possible indexes. Compute max of the first k elements of nums. That's max. Append this to the result. Remove the first k elements from nums. Return the lexicographically maximum array result that can be obtained after performing the operation. Operations. Where's my phone? Where's my phone? The max of an array is the smallest non-negative integer not present in the array. How would I know? How do you even calculate max? Is there a formula or is there an algorithm that I don't know of? You're telling me that I have to maximum max array. Lexicographically maximum array result that can be obtained after performing operations. Performing the operations. I have no idea. I don't even know what max is. What is max? What is MEX? NCP, minimum excluded. So I think I should spend some time trying to understand what this is and then come back to the problem. I will skip this second problem for now. I need what is next? Let me just read it and then I will end the recording and explain the how I solved the first question. The first question was straightforward, but still I'll explain it. Back to back videos on the same day, that's good. So max of a sequence. So what is max is the minimum excluded. Max of a sequence or an array is the smallest non-negative integer that is not present in the sequence. The max of an array is that is not present in the sequence. The smallest non-negative number. So like 1, 2, like 0, does 0 count as well? No, I guess. The max of an array of size n cannot be greater than n since the max of the array smallest non-negative, not present in the array. Having this. Okay. How to find max of an array without updates. Without updates, you can do some stuff. Then there's a second method, which is a map. You make a hash map and do something. Okay, I will try to make a video out of this as well someday. As long as I don't forget that I have to make a video, I'll make it, and I'll also do some export notes. Right. Um, so let me just jump to the first problem. Okay, so the problem is digit frequency score. So basically, there's an integer n that is going to be given to you in the question. Your job is to find out the sum of d into frequency of d over all distinct digits d, where frequency of d denotes the number of times the digit d has appeared in n. You have to return this integer that tells me the score. So what the question is saying that you are going to be given an integer and you have to find how many times a digit is being repeated in that number. After you find that, you multiply it with that particular digit. So if I have an ith digit and that ith digit is repeated three times or four times, for example, I will add 3 into I into my score variable, the answer variable, whatever. Then I just have to output it. So as you can see, because the thing is that every single number that is greater than 10, like greater than 9 for that matter, uses the numbers which are in between 0, 1, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You can create all the numbers using only these 10 digits. That's how every single number, positive or negative number, is made. Or like integers for that matter, not that's even decimal numbers, you had a point. Any real number can be made using these 9 digits, right? So I just have to find a way to store the frequency of all these 9 digits for a particular number. So I just make an array that's of size 10. It's that simple as that because an array of size 10 is going to have indexes up to 9. So from 0 to 9. And since they are from 0 to 9, I can store all the frequencies of all those numbers for that particular index. I can use these numbers as an index. So that's exactly what I'm doing. I am making a frequency array. Why am I not able to zoom in? I cannot zoom in. Yeah. I make a frequency array and then I run a loop. And the job of the loop is to extract the last element. So for this 122, the last element is 2. I extract it and store it in the mod variable. Then I go to the frequency of this mod. Like go to this particular index, which would be frequency of 2, and I increment it by 1. This is what it's doing. Like plus is increment. Then I divide that number to go to the next digit in the particular number. And the ordering doesn't matter. You can start from the right or you can start from the left for the given number because I only care about the digits. I don't care about where they are present. I just care about how many times they are present. I just have to make sure I don't count the same digit at the same place twice. That's it. And this is exactly what this loop is doing. You just keep extracting from the right. You add the frequency to the frequency array, and you divide the original number by 10. That's how it's like extracting a digit. This is simple extracting a digit logic that people that you might have studied of extracting or extracting the last digits or like digits of a number from the right, that is, not from the left, from the right. Then I do, after storing all the frequencies, I just run a for loop which calculates the sum, the score of this number. So I just say, hey, the frequency is the number of times this particular index is appearing. It's greater than zero. I can just multiply it by how many times it has appeared. So frequency of I tells me how many times this number has appeared. And what is that number that is we are calculating right now. So just multiply it by I and add it to the answer. That's it, and you can just return the answer and it works. This is the intuition for this problem. I don't know how much time it took me, but it was quite fast, I think. Anyways, this was a this would have been a terrible contest if I participated. A really terrible contest because I would have been stuck on the second problem for like two-thirds of the contest, and then I would have opened the third problem because I don't think I even would have opened the third problem because it's an extension to the previous problem, I think. Whatever, and then you just don't open the fourth program. I'm not on that level yet. So that's it. All the best. And my condolences for everyone who participated in this contest.